Hi guys, so I'm Robert Cleeley.
And I'm Taspias Liss.
So we're just picking up the factor analysis that we started to do previously on our purchase intention factor. And what we found when we looked at the loadings was that one item scores quite weakly.
Yeah,
actually, let's just, before we go too far, I mean, let's just say to the students, we're looking at this column ML1. I don't know what ML stands for.
Maximum likelihood 1, yeah.
And
so
it's
the first
this
model.
This column here is the
loadings
on the
factor
factor.
Loadings, yeah.
Which could be understood as the relative importance.
Yeah. And then the other column, so the last column is the communalities. So the communality is the degree in which the two variables have certain things in common. So the communality is essentially the addition of the other two columns. So H2 and U2. U2 is U squared, essentially. It's the uniqueness. So that index represents the uniqueness of each variable, and we can see that in our case PI2 has a very high uniqueness, which means that the variance this item represents in our scale is unique compared to the rest of the variables. The H2 represents, again, it's H squared. It represents the commonalities or the common part that the variables share, and again we see that for the second item that common part is very, very low as such. So we need to examine or think why that might be the case for this item.
Yeah, and we were just talking before we pressed record about why it might be the case.
Yeah.
And we immediately noted that this item was the one that we chose to reverse code.
Yeah.
And there's several reasons why that reverse coding might not have worked. One, it might have been confusingly worded.
So if we go back to the questionnaire,
which is here.
Yeah. So in the questionnaire, we decided to reverse code it exactly because the directionality of the item was different to the other items. So the second item says, I would seriously consider my purchase, which means I would really think about purchasing summer clothes. So I wouldn't be certain about my purchase. So that means that is a negative statement. It has what we call negative valence or negative quality as such. So that's why we recoded it, and our choice is correct for this particular data set. The problem is that possibly the wording or possibly the fact that this is one of the last questions in the questionnaire, for some reason it might have confused the respondents, or an alternative explanation is maybe the respondents were tired by that time, so they didn't pay attention to that question.
Or they just saw that we're near the end.
Exactly.
Tick, tick, tick.
Yeah, and so there are a lot of reasons why that item might be misbehaving. In our case, the easiest thing is to just take it out of our model or of our analysis and go on with the other three variables. Four.
Yeah. Well, so
yeah.
If we wanted to do that, and here's a little shortcut. If you press the up arrow on your keyboard, you can go through your previous lines of code.
Yeah.
So what we could do is we could go into purchase intention, and we could take that item out. But I'm going to suggest Tassos.
Okay.
We don't do that.
Okay.
And I'm going to suggest that what we do is have a look at a reliability analysis. Because that might also give us a reason whether the factor is improved if we take that item out.
Yeah.
So I know again that in psych it has a function called alpha.
Okay.
And that if we give alpha the data
set. Okay.
And we just want, I think we call it purchase intention, didn't we? Let's just double check. Purchase intention. Yeah. We just want the items from this factor.
Yeah.
But we want all of the data still.
Yeah.
We want all of the rows. So we can create this object and once I pressed enter, we got an error message, so hopefully it's worked.
So I'm seeing here we didn't put any parameters. Is that because alpha doesn't have any, or we don't need them?
Well, we did give it a parameter in that we gave it the data.
Yeah, okay.
So we have given it a
besides
parameter.
The data,
I'm not sure if there are parameters for this one. I guess fine. I would probably throw that back to you as the stats experts, but what we could do is we can go to the documentation, which you'll see is well looked at for me. And if we try to find alpha, let's see what parameters we can put into it. So here it tells us it's internal measures of consistency, blah, blah, blah. Yeah. Aha, and so look, here we've got the usage, type alpha, and then these are all the parameters that we can put in.
Okay.
So X is our data frame or matrix, our data.
Yeah.
Keys, if some items are to be reverse keyed, titles, cumulative, max, number of iterations, delete items, number of observations, whether we want to impute missing data.
So it has a lot of possibilities.
There's lots of things that you can do. What you'll find, this is a good example where if we don't specify any of these, it's still going to work, but it's going to make some some assumptions. So for example, n obs is what to do if there's missing data. Well, we don't have missing data, we don't need to worry about that. But this is a good example where you might need to look at the documentation and check you know what you're doing. So now we've done this, we've created this object.
Call CR.
Call it. We get...
So we get the output. Okay, so we have several things again. Some of these are common with other packages, some of them are not. I need to see if I read them correctly. So the raw alpha is the raw alpha index, which is an indication of the reliability, of the current reliability of the object. Or
it's sometimes called the internal consistency, isn't it? So how much do the items fit together?
So as we were saying before, the idea behind psychometric scales are that they are mostly summative scales. So the idea of internal consistency is that indeed all of the items measure the same or a similar concept, that the thing that they measure is very close, that allows you to actually sum them up and use them as a whole. The raw alpha is what we tend to see reported in papers. However, it's something that we cannot compare across factors or across models of the same factor. In order to have comparability, we need to use the standardized alpha. The difference here is small, and it should be small, the difference between the raw alpha and the standardized alpha, and that difference mainly has to do with the size of the sample and the distribution characteristics of each variable. Then if I'm reading things correctly, we have an average R. I'm not sure what all these output is.
Well, I think one of the things
mean as the mean, standard deviation, and median. I think these should be, so the mean should be the scale mean, and the standard deviation should be the standard deviation of the scale, so all of the items together. It gives confidence boundaries for alpha, which is really good. Most statistical packages do not do that, so you know the fluctuation of your raw alpha, which shows us that it's even robust. And what we're mostly interested in is what happens to the reliability index if we drop one item. So again, we get the raw alpha, the standardized alpha, and all the other metrics, and we can definitely see that if we drop the second item, both the raw and the standardized alpha will go up. So in a lot of cases, when we are discussing or thinking about whether to drop an item, we take a look at the reliability analysis, and if we get the information that dropping the item will increase the reliability, usually it helps us to make that kind of decision.
And I guess if we think of the factor as being summative, then each item's meant to add.
Yeah,
to
exactly.
it.
Yeah,
and in this
yeah.
case, when we looked at the results of the factor analysis, we could see it wasn't very important in
Yeah.
terms of its loading.
Yeah,
It didn't really add much to
Yeah.
the factor.
yeah, yeah,
And what this is now telling us is that as a consistent measure,
yeah.
actually it makes it less consistent
Exactly. Yeah,
having it in.
yeah,
So if we
yeah.
take it out,
Yeah,
the factor should be better.
yeah, yeah,
So we've really justified, I think, at this point,
yeah.
rewriting
Hard
the
to-
model,
Yeah, exactly. Yeah,
taking it out.
yeah,
We'll do that, and I think whilst we do that, we'll let the students go and do it,
yeah.
and then we could perhaps do an ANOVA or some kind of test to
Yeah.
see which is the more
Yeah.
reliable model.
Definitely. Yeah.